Welcome back, guys. So this is question 2.1 of our book Electric Circuit by Nilsson. So from today we have been starting the exercise questions of this book. So let us first start by question 2.1. So the statement of this question is the interconnection of ideal sources in the circuit in figure 2.1 valid or not? Explain. Okay, so the first thing here is that whether these connections are valid or not. So these are all the independent sources. This is the independent voltage source, this is one, is also this one is the independent current source. Okay, so what is here and what should I consider for the validity of this? So the circuit will not be valid if it is like this one, the two voltage sources are connected, two or more voltage sources are connected in parallel in such a way that it has some voltage 15 volts and it has some voltage 16 volts or 20 volts. Somehow voltages are different in between both of them. Okay, so that these two connected are in parallel, and we know that in parallel the voltages will remain the same. So therefore this one is incorrect and it is not valid electric circuit. Okay, similarly another type of circuit is that if the two or more current sources are connected in series are not similar. Okay, so suppose this is the 5 amperes and this one is 10 amperes or somewhat different than this 5 amperes. So in this branch, in this series branch, we know that always the current remains the same. So therefore these type of circuits are also incorrect as well and are not valid circuits. Okay, so these two type of circuits if are not available, or if you can see any other combination just like these one, so you should keep in your mind that these connections are invalid. Okay, so looking at this circuit, there is nothing like this one. This is the voltage source, this is the voltage source, both of them are connected in series with each other, which is invalid. It doesn't satisfy this one, it doesn't satisfy this one, and this is a valid combination. Similarly, this current source is connected in series with these two voltage sources, and similarly this is the only current source here. So therefore the current through only this branch is 5 ampere. Okay, so therefore this one is the valid electric circuit. Okay, so that is the explanation for part A. Okay, so let me remove it. In part B of my question, identify which sources are developing power and which sources are absorbing power. Okay, so to discuss that which are these sources which absorb and which develop the current, let us first consider this current which is flowing in the clockwise direction. So here in considering this one, we can see that this is the current and here this current flows from positive to negative. Okay, so this one is leaving out from this terminal, and as this is the conventional or ideal circuit, so therefore we are considering the conventional current. So therefore when it will enter through positive and will come out of this negative terminal, so therefore this will be the absorbing source. Okay, so therefore let me write here V20 20 volts. This is what? This is the absorbing source. Okay, similarly here you can see that here the current is entering through negative and coming out of this positive. So therefore this is what? This is the developing power source. So therefore here we have V15 and that is the 15 volt source which is the delivering or developing power source. Okay, similarly here we can see that this is the current which is coming out of this one. So this is positive, this is negative for the current source. You should also keep in your mind that this should be the polarity here if nothing is given. So here again current is entering through this negative and coming out of this positive. So therefore this I 5 amperes is the 5 ampere and this is also the developing or delivering source. Okay, all of them are the sources. So these three are explained here. part C of it is verify that the total power developed in the circuits equal the total power absorbed. Okay, so let me solve it, and this is part C. So first let me find out all the absorbed power. Okay, so the only absorbed power is through this one, which is P20. Okay, so here this would be I20 multiplied by V20. Okay, which is what this V is the voltage across it, and I20 is the current which is flowing through all of this circuit. And we should keep in our mind that this is the series circuit, so therefore I20 is equal to the I15, which is equal to 5 amperes as given here in this branch. Okay, so the current through all of this is same, so therefore the I20 is 5. Okay, and the V20, which is already given here, is that is 20 volts, so therefore it is 100 watts. Okay, similarly the other one is the developed power. So let me write here about the developed power. So what is the developed power? So the total developed power is the power which is developed by this 15 volt source plus this 5 ampere source. Okay, so therefore the power developed by this 15 volt source is I15 multiplied by the V15 plus the power developed by this current source is I5 multiplied by the V5. Okay, so do we know this value? Yes, this is already known, and also from this formula as well. Do we know this value? Yes, this is already known from it as well, and that is 5 amperes. Okay, this is the I5. Do we know this value? Yes, V15 is known, and that is the 15 volts. But do we know this value? No, we don't know this one. So therefore, in order to find it out here, let me find it out here. Applying KVL through this loop, we will see that if this is the current, we will see that this is the 20 volts. Okay, minus 20 volts, and if this is the positive, so this is 15, and also this one is what the power through across it is V5, so this is equal to 0 according to the Kirchhoff's voltage law. Okay, so V5 here would be what? It would be the 5 volts as from this one. Okay, so let me write these values here as we have found it out. So let me write these values. This is 5 multiplied by 15 plus how much is this? This is 5 multiplied by 5. Okay, so it would be 75 plus 25, which is 5 multiplied by 5, so this one is 100 watt as well. Okay, so this one is equal to this one, so therefore both the power developed and the power absorbed are the similar ones. Okay, so this is what this is from part A to part C, and for part D I will solve it in our upcoming video. Till then, take care of yourself, and if you have any question, you can ask me in the comment box. See you soon.